morning. Suppose we have circuit like this and we have to calculate the current flowing in the branches. First thing to do is to do one transformation, star delta transformation. We can transform this one or this one. Okay, and later we can calculate the currents. We calculate the equivalent resistance of this circuit. We calculate ER1 and later we calculate the whole current using current divider. I'm going to use only current divider. I will explain how to use voltage divider. Let's transform this star into delta. Here the result, if we transform it, we have the following circuit. We have R6 prime, R4 prime and R5 prime. From here we can calculate R4 prime divided by R4, R5 prime we divided by R5, R6 prime we divided by R6, and here it's numerator we have R4 times R5 plus R5 times R6 plus R6 times R4. Same here and same here. And the result here we find 300 over 10, that is 30 ohms. Calculated here. Here it's 50 ohms and here it's 20 ohms. From here we go and calculate the impedance, equivalent resistance. I'm sorry, equivalent resistance. We see these two are in parallel. These are in parallel, and later they are in series. We use this one, and later these four are in parallel with R4 prime, and later these two are in series with the whole. So here 60, 20 in parallel gives 15 ohms. This in parallel with this 75, 50 gives 30. And if we do the sum of these two, let's call it R4 second. This is 45 ohms, and adding these two will give us 18 ohms. Adding this plus 18 plus 3 plus 9 will give us 30 ohms. And from here we can calculate ER1 is equal to V over R equivalent, and this is 60 over 30, it's 2 amps. Now we go and try to calculate the other currents. Here we are going to use a current divider. I will explain these four resistances. I call them R4 second, and here I will use the current divider. I will give you the equations. I think you remember. First of all, I have R4 prime and I4 second that are in parallel, so I can calculate the current flowing here and here in this resistor and in this resistor, the whole resistor. IR4 prime and IR4 second. This is R4 prime over R4 prime plus I4 second times IR1. Here it's R4 second prime, R4 prime plus R4 second times IR1, and here R for second is 45 over 45 plus R4 prime, R4 prime plus 30 times 2. Here it's 30 over 75 times 2. So it means here 45 divided by 75 times 2. Here it's 1.2 and here it's 0.8 amps. So we calculated this current and the main current, but we can calculate IR2 and IR6 prime using current divider. This one is R6 prime over R6 prime plus R2 times IR for second. Here it's R2 divided by R6 prime plus R2 times IR for second. We can calculate this current as well, IR3 and IR5 prime. IR3 is R5 prime over R3 plus R5 prime times IR4 2 prime. This is R3 over R3 plus R5 prime times IR4 2 prime. So here first, this is 20 over 20 plus 60 times IR 0.8, 0.8, 0.8. So here it's R2. R2 is 60 over 80 times 0.8. So it means 20 times 80 times 0.8. It's 0.2 amps, and here the difference 0.6 amps. And now we calculate IR3 are 50 over 125 times 0.8 IR5 prime. It's R3 is 75 over 125 times 0.8, and it's 50 over 125 times 0.8 or 0.32, and this one 0.48 amps. So now we can calculate the current where we need ER5. This is ER6 prime plus ER6 prime plus ER4 prime, ER6 plus ER5 prime plus ER4 prime, and IR4, this is IR5 minus IR5 minus IR6. So this one, IR6 prime, I calculated 0.6, IR4 prime plus 1 over 2.2 point everywhere, 1.8 amps, and here it's IR5 prime 0.48 plus 168 amp, and the difference is 1.8 minus 168 is equal to 0.12 amps. And we calculated all the currents. We can use, of course, the current voltage divider to calculate all the currents. I will explain. If you use voltage divider, then to proceed this way, we have IR1. We can calculate this voltage using, let's call it, using a voltage divider. We have to know this resistance equivalent IR for prime in parallel with R for second. This is calculated, it's 18. So we can calculate VR for prime. It's 18 over R equivalent, which is 30, times the main voltage, 60, so times 60. From this we can calculate ER for prime. It's VR for prime over R for prime. Once we have this, we can calculate the voltage at this resistances VR2 plus, which is equal to VR6 prime. Using the, we have to know this equivalent resistance, which is 15 over the sum of these two, which is 15 plus 30, 45, times this voltage, VR for prime. And from here we can calculate VR6 prime. So this is VR6 prime, VR6 prime is calculated. We can calculate ER2, it's VR2 over R2. We can calculate ER6 prime, it's VR6 prime over R6 prime, and later we can calculate this voltage, which is VR3, which is equal to VR5 prime, and voltage divider, we can use it. It's 30 over the sum of the two, which is 45, I think, 45 times the main voltage, which is this one. And from this we can calculate ER3. This is VR3 over R3, and we can calculate ER5 prime, which is equal VR5 prime over R5 prime. And that's it. We can use current divider, voltage divider, and Kirchhoff's law to calculate all the currents. And thank you very much.